Hi everybody, so in this video we're going to talk about how to complete a square. First of all, what is this used for? Let's say if I have an equation in a standard form right here, I'm going to use completing square to turn my equation into the vertex form. So then I can actually easily graph it, right? Because we know how a vertex form is actually going to show us how our parabola is actually shifted on the plane of x and y axis. We're going to actually use this method to be able to write our equations in a vertex form and therefore be able to easily graph it like we've learned in a previous chapter. Now, let's take a look and see what it means to have a perfect square. For example, 25 is a perfect square. Why? Because if I took the square root of it, I will have 5. Right? So it's the perfect square of 5 because 5 times 5 is 25. Now for another example, 36 is the perfect square because the square root of it is 6 and 6 times 6 is 36. Is 11 a perfect square? Absolutely not, because there are no two numbers that I can multiply together and get 11. Let's take this a little bit further. So let's look at the expression x squared plus 8x plus 16. I can actually have this equal to 0, and this is the equation in the standard form. Now, is this a perfect square? What does that mean? That means that could I have two expressions multiplied by each other so that it would give me x squared plus 8x plus 16? Looking at this, the first term is a perfect square of x, and the last term is a perfect square of 4, and the middle term is just 8x. So if I had x plus 4 to the power of 2, will I get x squared plus 8x plus 16? Yes, because I will, if I were to expand this, I will have x squared, and the last term, which is 16, and the middle term is always 2 times 1 times 4, which is 8x. Therefore, it is a perfect square. Let's take a look at another example. So let's say if I have x squared minus 10x plus 25 equals 0. Is this a perfect square? The first term is a perfect square of x, and the last term is a perfect square of 5 because the square root of 25 is 5, and the middle term is just the coefficient of x, which is 1, times the square root of the last term, which is 5, multiplied by 2, and a negative actually, so it's times a negative, so it would be a negative 10x. Therefore, this would be a perfect square root of x minus 5 to the power of 2. And if you don't believe me, you could go ahead and expand this and you will get the same result as we had over here. Okay, well, let's take a look at another example. Let's say if I have x squared plus 6x minus 3 equals 0. Now, is this a perfect square? Well, let's take a look at the terms. So the first term is a perfect square of x. The last term, the square root of 3, doesn't give me a perfect number, right? Therefore, it's not a perfect square. What I'm going to show you in this video is how to turn this expression to the vertex form. So a parenthesis or a coefficient, x minus h plus k. So this is what I'm going to turn it into. Now I'm going to actually show you a trick that you can actually use to turn this into a perfect square. What I usually look at is to see if they have anything to take out as a common factor. Now in this case, because x doesn't have any coefficient, they don't all have anything in common. Therefore, I'm just going to write the first two terms, and make sure if you follow these steps, you will never have any problems completing any square from now on, okay? So I write the first two terms. Now my last term is going to be my middle term divided by 2, which is 6 divided by 2, which is 3, squared, which gives me 9. So what I'm going to do is that I'm going to add a 9 to this expression. And look at this. This is basically a perfect square. Why? First term is a perfect square of x. The last term is a perfect square of 3. And the middle term is just a coefficient of x, which is 1, times the square root of my last term, which is 3, multiplied by 2, multiplied by x, which gives me 6x. Because these three things check out, there's a perfect square of x plus 3 to the power of 2. Now, I know this, but you know what? What I did here is I kind of disregarded this 3 over here and I added some random number to this equation. Well, you can't just add a random number to an equation and expect the equation not to change. So what you're going to do, you're actually going to subtract the equation by the same number, because plus 9 minus 9 is equal to 0. So this just means that you're adding a 0 to this equation, right? Therefore, you're not changing the equation. And then we're not going to forget about the minus 3 here. So I'm just going to take that and write it over here, equals to 0. Now the next step would be completing the square, actually. So what you're going to do is that you're going to take the first 3 term and write x plus 3 to the power of 2 instead. And then you're just going to add the rest of the numbers together. So negative 9 minus 3 is just negative 12. And there you have it. So you have this equation written in the vertex form. That's it, you're done. Now, what is this used for? So this is basically a parabola, right? With a vertex of, your vertex here is negative 3 and negative 12. So this is your vertex, meaning that if you had a parabola here, right? If this is your original parabola, it would be shifted 3 units to the left and 12 units down. Well, this is a very rough sketch, but I just wanted to show you this is how it's going to look like. This is why we did this. All right, let's move on to the next example. So for my next example, I'm going to do the same thing. I'm going to take a look and see if all 3 have anything in common. Well, the coefficient of x squared is 2. So what I'm going to do here is to take out the 2 from all of these terms, meaning I have to divide every single term by a factor of 2. And then I'm going to write it like that. So 2x squared divided by 2 is x squared. 16x divided by 2 is 8x. And 30 divided by 2 is just 15, equals 0. Now this looks a lot like the example we had on the previous term, x squared plus 6x minus 3. So I'm just going to use the same exact method to factor this out. So I'm just going to write 2 as is, and I'm going to write the first 2 terms like I did in the previous question. Now my extra term, my perfect square term, would be 8 divided by 2, so the middle term divided by 2, which is 4. Then that to the power of 2, which is 16. So I'm going to have to add a 16 to this to make this a perfect square. Now, because I can't just add a number to an equation, I'm just going to have to subtract the same amount from the equation. And then I will not forget about my last term, which is positive 15. So I'm just going to write that out, close my bracket, and equal the whole thing to 0. Now, we've learned that this is a perfect square because the first term is a perfect of x, the last term is a perfect of 4, and the middle term is a coefficient of x, which is 1 times 4 times 2 times x, which is 8x. Therefore, this would just be x plus 4 to the power of 2. And then I'm just going to add the last 2 terms that I have here. So minus 16 plus 15 is just negative 1. So I'm just going to write that here, equal to 0. Now my parenthesis here is very important because what I want to do is to expand the 2 into these 2 terms that I have here. Therefore, my final answer would just be 2 multiplied by the first sentence here, minus 2 times the last term, which is minus 1. 2 times minus 1 is just negative 2, equal 0. So this is my equation in the vertex form. Now, what do I know here is that my values, if I were to look at the standard form of a, x minus h to the power of 2 plus k, my a value here is 2, my h value is negative 4, and my k value is minus 2. So what I know is that a is going to stretch my graph in the y direction, h is going to move my graph 4 units to the left, and minus 2 is going to move my graph 2 units down. So how is this going to look like? My graph is just going to be a regular parabola that is shifted 4 units to the left, 2 units down, and the y value, as opposed to have a 1 1 and 1 1 here, it's going to be multiplied by 2. So it's just going to look something like this. There you go. That's about it. This is going to be a rough sketch. We're going to talk about finding the roots in a different video. Now let's take a look at another example. So in this example, I want to take a look and see if I can take out anything. My coefficient here is -3, and the -3 is not common in all three terms. Therefore, I cannot factor anything out of all three terms here. But what I've learned is to deal with things that don't have a coefficient, just like we did here, and just like we did in the previous question over here. There's no coefficient for x. So what I want to do, every time I see anything with a coefficient, I kind of want to get rid of it no matter what. So what I want to do, I want to actually try to at least take it out from the first two terms. So I'm going to use this trick, and I'm going to divide this by -3 and divide the second term by -3. So I'm going to have my -3 factor out, and then I'm going to be left with -3x squared divided by -3. I'll be left with the x squared. -18 divided by -3, I will have a positive 6x. And what I'm going to do is that I'm going to close my bracket here, and I'm going to write -17 outside, because I don't want to divide it by 3 and get a random number, and a number with decimals. So I'm just going to leave that out. Now, what I'm going to do is that I'm going to focus in what I have in the bracket here, and I'm going to try to complete this square. Now, I don't have a coefficient for x, and this is a perfect square here. So what I'm going to do is that I'm going to find another term to make this a perfect square. So how do I do that again? I'll take the middle term divided by 2, which is 6 divided by 2 is 3. Square it, so it's 9. Then I'm going to add a factor of 9 and subtract a factor of 9. So I'm not really doing anything to the equation. I'm just adding a 0. Then I'm just going to write this as -3. And the first 3 term for me is a perfect square of x plus 3 to the power of 2. We've seen that in a different example as well. So I'm just going to write that out. And then I have a -9. Close the bracket and write the -17 outside, exactly how it was before. Now the next step is to actually involve this 3x and expand it into the bracket that I have here. So this whole thing is going to be equal -3 times x plus 3 to the power of 2. And then I have a -3 multiplied by a -9. So I will have a positive 27. Now I got rid of this bracket, so I don't have these big brackets anymore. Therefore, I can just write -17 as it was. So what I did, I just eliminate the bracket. That's it. Now I'm just going to add what I have left here. So I'm just going to write the first few terms, and I have a positive 27 minus 17, which is just a positive 10. There you go. I have another example written in a vertex form. Now, if I were to compare it to my actual original equation, I will have my A as -3, H as -3, and my K as a positive 10, which means that I'm going to stretch it vertically by a factor of 3. I'm going to flip it on the x-axis. I'm going to move it to the left -3 units, and I'm going to move it up by 10 units. So if I were to actually graph this on a plane here, my vertex is going to fall in -3 and 10, which is going to be right here. And instead of having my 2 points at 2, 1, 1 here, and then at 4, 9 here, I'm going to have the y multiplied by 3. So it's just going to be multiplied by 3, 1, 2, 3. So my first point is going to fall over here. So this is how my sketch is going to look like. And actually writing it in a vertex form has helped me graph this. So in this example, I have a coefficient of 2. Can I get rid of this 2 over here? Yes, because all of my terms have a 2 in common. So I'm just going to divide each term by 2. So my factor of 2 is going to be outside of my bracket. My first term is going to be just x squared. 10x divided by 2 is just 5x. And the last term is 8 divided by 2, which is 4. Is this a perfect square at the moment? Let's take a look. The first one is a perfect square of x. The last one is a perfect square of 2. The middle term should be 1, which is the coefficient of my x, times the square root of my last term, which is 2, times 2 times x, which gives me 4x. And it does not equal what I have here. Therefore, this is definitely not a perfect square. Now, what do I do to turn this into a perfect square? I'm just going to write the first 2 terms like I did before. So 2 doesn't change, x squared plus 5x. Now, what I'm going to do is that I take the middle term divided by 2, which is 5 over 2. Then I square it to the power of 2, which is 25 over 4. Now, you might want to write it as 5 over 2 is 2.5, and then have 2.5 to the power of 2, which is 625. Now, I'm going to use this form because a lot of students are not allowed to use calculators, so we know actually how to do this. So what I'll do is that I'm going to add a 25 over 4, and I'm going to subtract a 25 over 4. I'm just going to treat it like the values that I had before, like nothing has changed. And I'm just going to add my plus 4 in the bracket because it is already in the bracket. Now, what is the next step? The next step is to write the first 3 terms as a perfect square. So as I always do it, I'm just going to write 2x plus the square root of the last term, which is 5 over 2 to the power of 2. Now what I'm left with, the last 2 terms, which I'm supposed to add like I did in the previous question. So negative 25 over 4 plus 4. How do I do this? Now, in order to do this, I actually need to do a common denominator. And the common denominator of the 2 numbers is just 4. If you're not sure how to do this, watch our video on doing a common denominator and you'll have no problem doing this at all. Now I'm just going to write minus 25 on top, plus 4 divided by 1 is 4, multiplied by 4 is 16. Therefore, minus 25 plus 16 is just negative 9, so minus 9 over 4. 9 over 4. Then I'm going to close the bracket. And I'm not going to forget I had a bracket right over here. Now what I need to do is to actually expand the 2 into this bracket. So I will have 2 times x plus 5 over 2 to the power of 2 minus 9 over 2. Why? Because 2 times minus 9 over 4. 2 is going to divide by 2, which is 1, and 4 divided by 2 is 2, so I will have minus 9 over 2, which I'm going to write here. Now, if you actually did this using your calculator, you should have 2 times x plus 2.5 to the power of 2 minus 4.5. And looking at the actual vertex form, your A would be 2, your H would be negative 2.5, and your K value would be negative 4.5, and your vertex is just going to be minus 2.5 and minus 4.5. So let's draw a sketch of this very quickly. So I know that the vertex is minus 2.5, so it would be somewhere right here, and my actual y would be 4.5 down, so my vertex is going to look like it's going to be here. Now it's going to be opened up, and my first points are supposed to be 1 here and 1 here, but because it's multiplied by 2, it's going to actually shift up by 2, so it's going to be stretched vertically, and my 2 over here is going to be here, so it's going to be kind of compressed in this direction and stretch vertically, right? Very good. Moving on to the next example. So this is very similar to the previous one that we just did. Now looking at my x, I have a coefficient which I want to get rid of because I don't like it. I don't know how to deal with it if I have a coefficient behind x. So I can't take it out of all the three terms. So what I'm going to do, I can take it from the first two, which is easier. So I'm going to write my factor out, divide these two terms by -3. So I'm just going to be left with x squared minus and plus 9x divided by -3. I will have a -3x. I didn't divide -2 by -3 and I didn't factor that out. It would be left out outside of the bracket. Now what I'm going to do, what I do best, I'm going to take the middle term and I'm going to divide it by 2. So I have 3 divided by 2. Then I'm going to have it to the power of 2, so which is 1.5 to the power of 2. And that is 2.25. Again, I'm going to deal with fractions here, and I'm going to write plus 9/4 minus 9/4, because 3.5 to the power of 2 is just the numerator to the power of 2 and the denominator to the power of 2. There you go. So now that I have it, I'm going to use the first three terms to write it as a perfect square. So I'm just going to write -3 outside of the bracket. And what I will have here, I will have x and 3/2, which is the square root of the first part. Now in the middle, I will have a minus sign because I have a minus sign here. And because if I have x minus 3.5 to the power of 2, I will have x squared plus this last term to the power of 2, which is 9/4, and the middle term would just be the coefficient of x, which is 1, times the last term, which is -3/2, times 2 times x, which is going to be, these two are going to cancel out, so I'm going to have -3x in the middle and then my 9/4. Right? So I'm going to write that as is, and then I have a -9/4 over here inside the bracket closed, and my -2 is going to remain outside of the bracket. Now the next step would be to expand the 3 into this bracket. Therefore, I will have -3 times x minus 3/2 to the power of 2. And then I'm going to have -3 multiplied by -9/4, which is just going to be negative times negative is just going to be a positive number. 9 times 3 is going to be 27/4. And then now that I got rid of these two big brackets, I'm going to write -2 as it was before. Now this looks more and more like a perfect square. Now what I have to do is to add these two numbers together to be able to write it as 1. Now how do I do that? I'm just going to show you over here. And then I'm going to have 27/4 minus 2. I'm going to use common denominator. So this will have a 1. And 4 times 1 is 4. 4 divided by 4 is 1. 1 multiplied by 27 is just 27. 4 divided by 1 is 4. Multiplied by 2 here, I will have 8. 27 minus 8 is just 19/4. Therefore, my final equation in the vertex form is going to be what I have written already, plus 19/4. This shows you that my a value here is -3, so my parabola is going to be upside down. My h value is going to be 3/2. It's going to move right by 3/2, so 1.5 units. And my k value is just 19/4. Or just 4.75. If you put it in the calculator, that's the number you're going to get. All right, so let's take a look and see how we can graph this. So my vertex is just 1.5 and 4.75. It's going to be somewhere here. Now we know that it's going to be upside down parabola. And now my first points are usually supposed to be here and here. However, I'm going to actually have it multiplied by 3. So 1, 2, 3. So my points are going to look like they're going to be somewhere around here. And instead of that, they're just going to be shifted 3 down because it's multiplied by 3. it's gonna look something like this. And there you go. This is a rough sketch for your equations. Now, there are lots of examples at the end of your books that you could do for factoring. If you have any questions, please comment on the video below, like and share and subscribe to our channel. And we will make sure to get back to you. We'll make a specific video just for you to address your questions. Thank you so much for watching.